I am Lori Ward. I'm CEO at Washington's National Park Fund. I often say to people, I have the best job in the world. I love working with and for our national parks. We all do. We have a strong board of directors, 23 individuals who give of their time, talent, and treasures, and very passionate people. We work very closely with Mount Rainier, North Cascades, and Olympic National Parks. We serve as their official philanthropic partner and love the work that we do. We get their priority projects at the beginning of the year, and then we set out throughout the year to raise the funds. We're actually having a really good year, and thanks to many of you who are watching. You know, they're trying times, but if you have the license plates, the national park license plates, that generates 25,000 to 30 a month for us. Very helpful during these challenging times. So we're doing well, we're holding our own, and we're run by a staff of 7 hardworking people. And so today we're looking forward to sharing more about shrinking glaciers at Olympic National Park. Before I introduce Bill, I want to share a quick story with all of you. It was probably 20 years ago. My husband Colin and I were hiking up at Glacier National Park. And we were hiking into this lake that you see behind me. And I'd be amazed if anybody could name the lake. I wouldn't be surprised because our Northwestern hikers are very passionate. This is Iceberg Lake at Glacier National Park. And we were hiking to the lake and we kept passing by this crew of the film crew. They had cameras and equipment, and we just kind of kibitzed with them, had fun talking back and forth. Colin and I got up to the lake and we were relaxing. They came down to us and said, could we interview you? And we were like, what's going on? They were from National Geographic and they were doing a story on this very lake on the shrinking glaciers. And it was quite funny because probably 9 months later, we heard that people had seen the footage on, very short, but on National Geographic Channel. And so that's my story, that's my memory of shrinking glaciers. With that, I want to share with you that I want to introduce Bill. Bill and I have worked together for the 9 years that I've been in the position. He has been the lucky fella to serve the national parks for 35 years. He began as a wilderness ranger, and for the last 20 years, he's been serving as a scientist studying the park's climate, glaciers, mountain lakes, and coastal ecosystems. In partnership with Washington's National Park Fund, Bill has been tracking the changes of the Olympic Mountains glaciers and helping all of us to understand the implications of the park's ecosystems. You're going to be amazed at some of the images that you'll see today. And so you get the experience to hear from one smart fella. And with that, Bill, thank you for your time. We appreciate it. And I turn it over to you.
All right. Thanks so much, Lori. And thanks everyone for joining me today. We'll jump right over to the, this is my first Zoom session, by the way, so I'll do my best. All right. I'm going to share my screen and we'll look at the PowerPoint. Let's see. Should be there. All right, so hopefully everyone can see this and hear it. And so we'll get started. And thank you, Lori, for all the support for our glacier work over the years. And we'll talk more about the important role that Washington's National Park Fund has played in some of this data. All right, I'm already experiencing a technical difficulty here, so I'll, let me see if I can. All right, I'm gonna pop out for just a sec, guys.
No worries, Bill, go ahead.
All right, for some reason, it is not advancing, so.
Okay, no worries, take your time.
Something we had not, let's see.
Bill often has participated in our spring dinner and auction by taking high donors who are the high bidders to a package up and over the Olympics and a flight with the Wright brothers at over on the peninsula. And people that have experienced that have absolutely loved it. They get to go up on a flight and learn firsthand about these glaciers. It's pretty incredible.
All right, I'm going to try it again. For some reason, it wasn't advancing for me.
No problem. I'll back out and you go ahead when you're ready, Bill.
All right, I'm going to attempt to share here. All right, can people see this?
We're good, Bill. Go ahead.
Okay.
Yep, there you go.
All right. So, yeah, and hopefully I'm not exactly sure why that didn't switch, but we'll try. So I always like to just start with talking about, why are we studying glaciers and why do we care what's happening with the glaciers? And this is, by the way, this is Mount Olympus, the tallest mountain in Olympic National Park. And we're looking at the very top of the Blue Glacier, which is the largest glacier in the park. And so first of all, and I think most of the folks that are involved with the Washington's National Parks Fund can understand that, glaciers are really important. We're a national park, and really they form kind of these beautiful and iconic backdrops to so much of the scenery in this park. So purely from the point of a visitor experience, it's just they're really important, and the idea that these things are changing, has implications for what we view. And I think that fits in with Lori's story about going up to Iceberg Lake, which used to have a glacier and now it has a lake. So while all the scenery is beautiful, our scenery is changing. And so it's important for that. And also just one of the small stories, but I think an important one, is that glaciers, they're a unique habitat for unique species. And this one up here on the right is a little ice worm, and they're what's called an extrema file. They're a small worm that lives within the ice of glaciers, and there's distinct populations of them in different mountain ranges all around the world. So these kind of unique organisms are living in these habitats that are changing and disappearing rapidly. So I think it's important from that standpoint. And then glaciers really, I think, are fulfilling a societal role right now, which is as an indicator of climate change. And a lot like, you see this really cute polar bear in the middle. They've kind of become, glaciers are another one of the key stories that really do a good job of telling us about climate change and maybe helping people kind of identify and understand what's going on. And we're going to talk a little bit about why they do such a good job of that. So glaciers, this is the Eel Glacier, which is one of our study glaciers. It's on Mount Anderson, kind of the second biggest mountain massif in Olympic National Park. And glaciers form because the Olympic Mountains and many of our Pacific Northwest mountains get huge quantities of snow in the winter. In this case, the Eel Glacier and Mount Anderson probably receives about 120 feet of snow. Typically, at its deepest, we'll go up and measure, we'll find 30 to 40 feet of snowpack at the end of the year. And in the summer, after 5 or 6 months of melting, you'll see what's left. And those are the glaciers. And so glaciers form in areas where more snow falls than can melt during spring and summer seasons. So it kind of is the leftovers from the winter. And because of that, glaciers are responding, glaciers are responding to climate. So they're great integrators of temperature, particularly temperature, and also sometimes a precipitation signal. And what this slide shows you is that when you have a cooling climate here in the Pacific Northwest, our glaciers grow. And when you have warmer climates, our glaciers shrink. And if you look, I think people can see my pointer, but what this shows is our air temperature departure from average. And so what it shows you up here is these are warmer than normal years, and this is a cooler than normal year, and then this is an average year. And this shows our response of the glaciers in terms of what we call mass balance, and we'll talk more about that. But you see is in warmer years, we see more melt on the glaciers. So our glaciers get smaller. And in cooler years, like 2017, we see that our glaciers grow a little bit. And so glaciers are responding to climate. And so for that reason, they're a great integrator of the climate signal, and they do tell us a nice story about climate change. And probably for us in the Pacific Northwest and around the world, really, glaciers are important because they are showing us what's going on with our winter snowpack. And the winter snowpack in the mountains of the Pacific Northwest and many mountains around the world, they're ecologically vital, for our aquatic ecosystems. They're feeding our streams and rivers. And here in the Northwest, as an example, we actually have, relatively warm, but quite dry summers. And so as that snow and ice from glaciers melts, it's acting as a reservoir of cold, fresh water that's flowing down and filling our streams and rivers during those summer months. And also that cold water is buffering higher temperatures. And this is really important for aquatic organisms. And in particular, and as many of you are probably aware, creatures like salmon, that are so important, so vital to the Pacific Northwest. And then also, the water is really a source here on the Olympic Peninsula in our Dungeness Valley, for instance, a big agricultural area. It's key for irrigation, and water is also used for industrial reasons and for power generation for those of you that are in Seattle, and also for our municipal water supplies. So it's really critical for us and so that's, I think, why it's an important indicator. And so why are we concerned? This shows projections of the temperature in the Pacific Northwest, and this comes out of the Climate Impacts Group at University of Washington. And for starters, why we're concerned is that what this graph is showing us is the predicted increase in temperature over the next century. And the gray in this graph kind of shows what has already been. And then we project along these red and blue lines. And this just shows two different scenarios. The red line is kind of as things are right now. The blue line is what our temperatures are likely to be if we take a lot of major political measures to limit carbon dioxide. So kind of figure we're following the red line at this point. And so scientists are projecting that temperature is going to continue to increase in the Northwest. And then another reason for concern is that, well, this is a great example here. We see a ranger. This is one of the things that I do for my job is we're measuring the winter snowpack. And every month we go out to these historic snow courses and we measure the snowpack. And you can see in these two graphs, these graphs go back from 1949, and we're seeing less and less snow in the mountains each year. And that's those brown or yellow trend lines going down. So we know that we have less snow in the mountains than we used to. And the other thing we know is that our mountains in the Pacific Northwest, and particularly the Olympics, they're relatively warm mountains. Our winter temperatures are fairly warm. And here you can see in the blue graph, we show the average temperature at Hurricane Ridge, which is kind of the typical snow-covered area, kind of a typical elevation for our subalpine in the Olympics. And you can see that the average winter temperature during the period of time snow usually accumulates is about 29 degrees. So we're within a very close margin of where snow begins to turn to rain. And so we're in a precarious situation in terms of much temperature change and what that means for snow accumulation and glaciers. So the other thing we know is kind of the status of our glaciers and where we're at. And so kind of based on these concerns, in 2009 and 2015, we followed up on a 1982 inventory and kind of looked at the status of glaciers. And we did this with these other groups, these participating groups, and then recently with some help from Washington National Parks Fund. And I'm only going to go into two aspects of it since I don't want to spend too much time and I want to get to some other topics. But the key part of the inventory is really identifying from that original inventory each of the features that was found. And then using an aerial photograph, we digitize, and so we can get the total surface area of each of these glaciers. And so what this does is we are able to kind of calculate a total area of glaciers in the park, in each drainage, and also kind of understand the number of glaciers. And so therefore we can look at change in area and change in the number of glaciers. And this just gives you an idea of kind of how that data can be used. So the blue lines show the delineations from 2009, and then we've superimposed them onto a 1990 image. And so you can kind of see, we see the shrinking of the terminus of the Eel Glacier, and that much of the Anderson Glacier has disappeared. Another thing that you'll notice is that there's more change on the south-facing glaciers than the north-facing. And that really just tells you that it has a lot to do with exposure to sun and the melting during the summer seasons, and less to do probably with accumulation on one side versus the other. And then so once we went through that exercise, both in 2009, you'll see the 2010 data there, and the 2015, we found some pretty startling results. We saw almost a 50% decrease in the area of glaciers in the Olympic Mountains in a 35-year period, which you'll recall is the amount of time I've been here at the park. So I like to feel like that was a fairly short amount of time in the grand scheme of things. So yeah, we saw a 46% decrease in glaciarized area, and we lost 118 glaciers, mostly small ones. The other thing we noted was that between 1900 and 1980, the recession rate, the change was relatively stable, but it doubled between 1980 and 2009. And then most recently, between 2009 and 2015, the rate quadrupled. So we're seeing kind of an increase in rate. And so that was something that was notable. And just to kind of help you guys out a little bit, and this is, they always say the old adage, a picture is worth 1,000 words. One of the other aspects especially for interpretation and outreach was we took some historic photos, and we went back and we tried to retake current photos just to give a really nice feel for how things have changed. This is the Humes Glacier on Mount Olympus seen from the Queets Basin. I like this photo because it says Bill giving it the once over, so it seemed like a good one for me. So here's that Humes Glacier again in 1907. And if you look at the red arrows, you'll just use those as reference as we kind of move through these. So here it is in 2006. And you can see that, and as you watch these, you'll see how the glacier really is no longer filling up, these deep cirques. And in a lot of ways, it's no longer, you'll see that the terminus has really pulled back. It's no longer going into these valleys. Let me see if I can bring that back for a sec. So again, you can kind of see there it is kind of extending down into the valley, and then it's really pulled back. And then here's the Blue Glacier in 1899. And again, notice how the cirque is very full and it's like overflowing down into these low valleys. And then here it is in 2008. And another shot here is you can see it kind of dropping down to its furthest extent, and then where it is now. And again, notice how this cirque is completely full of ice, and now it's very, it almost kind of appears empty. Here's the Fairy Glacier, and which by the way, Lori, I know you're out there, but now this is the Fairy Glacier in 1961, and now everyone calls it Iceberg Lake. And you can see there's no glacier in there anymore. And then a final one, Anderson Glacier in 1936. And this mountain is, 3,000 feet above the basin where this picture is taken. It's just to give it a concept of scale. And then here it is in 2016, the glacier almost completely gone, just some little tiny remnants there. So we've seen that there's been major changes in the glaciers, and it seems to be happening more rapidly at Olympic than anywhere else. And so for that reason, we really wanted to know, what are the next steps? What can we do about it? And Olympic, unlike Mount Rainier and North Cascades, part of our long-term monitoring program did not include glaciers, but we had scientists at both those parks and a good protocol for working on that. So we went to the Washington National Parks Fund and we said, hey, we're seeing some really rapid changes, and we'd like to know a little bit more about this, and we don't have any money. And that's where the Washington National Parks Fund stepped in. And so starting in 2014, they've been able to fund our annual work, which ties in really well with Mount Rainier and North Cascades, and really kind of completes what should have been a complete 3-park monitoring program. And so I just want to kind of say we're really thankful for that, and it's provided some really great information. And so what we're doing is we're doing these annual mass balance studies. And what I just want to show you is this is kind of the workings of a glacier. And you can see here on the right, this is kind of a simplified model. At the highest elevations of a mountain, what's happening is we're getting more snow accumulates every year than can melt, as we talked about. And then that forms ice, which is then slowly slipping down the mountain to elevations where more of where more of the snow is melting each year. But because it kind of moves down the mountain, you get this remnant. And you can see that here too, where you have, this is remnants of previous year's ice with all the crevasses. And then this is the snow from the previous winter. And so what we do is we go in each spring and we make a spring visit into these glaciers. And we study 2 glaciers, one on Mount Olympus and one on Mount Anderson, the Eel Glacier. And we go in and we measure the depth of the snowpack. And you can see that here, we're using a long probe. Oftentimes we're probing down 30 to 40 feet through the snowpack until we hit the previous year's ice. And so we get an idea of the depth of snow at along these various transects at different elevations. And then we also, on the right here, you see a snow core. And so we're coring the snow and then weighing it. And that gives us an idea of the density or the amount of water that's being held in that snowpack. And then the other thing we do is we go in with this is a steam drill, which is kind of like a oversized, backpacking stove, where we boil water and then we jet steam down through this flexible tube with a tip. And so we drill this hole through the snow and all the way through the snowpack down in the previous year's ice. And then we place a stake made out of PVC pipe on the right here. You can see it going in. These stakes are usually around 35 to 40 feet long. We assemble them out of PVC and they're marked just like a ruler. And so we make the hole and then we drill the hole and then we drop these things in. And we do this, here's the Eel Glacier again, we do this at multiple elevations because we're going to expect that at higher elevations, there's maybe more snow and less will melt. And at the lowest elevations, we'll have more melt than snow accumulates. And so we do that and then we leave the glacier. And then we come back in the fall and we see how much of that stake is protruding from our ice or our snow. And that's going to tell us how much snow and ice melted in a given year at each elevation in the glacier. And then we apply that, and this is a little bit of a funny graph, but I hopefully can explain it. What this shows is the blue upward columns are showing, oops, sorry about that, guys. I think it must have been, are showing how much winter snow accumulated. The red is how much snow and ice melted. And then when you subtract the red from the blue, we end up where these little diamonds are. And so you can see these were negative years for the glacier. This is almost a neutral year, and that was a slightly positive. So that's the data that we get. And then we and then we're able to use a simplified model, and that can tell us a really important thing, which is how much snow and ice melted at every elevation within these basins. And so how much water was contributed to our streams and rivers during a given season. And that's what this graph shows here. You can see, for instance, in a really warm year, in the Hoh Valley, the summer water almost it looks like almost 27% of the water flowing in the Hoh River was coming directly from glaciers. So kind of giving us an idea of how important that water or how important that glacier is to the flow in that river. And also if those glaciers weren't there, what might happen. And so looking ahead to the future, this is a picture from 2015, one of my volunteer field partners, and we're doing a snow survey, and you can see he's on his skis and there is no snow. So I just want to kind of end this by talking a little bit about water year 2015. And some of you may be familiar with Cliff Mass. He's a meteorologist from the University of Washington. He does a really great blog, and he coined this term. He says, water year 2015 was really a climate stress test for the Pacific Northwest, and we're going to talk about why that is. This is some of the data that we collect here at the park. This is the air temperature, and again, this is the departure from normal. So 0 would mean that this was a very normal temperature in any given month. And what you can see is in 2015, we had an incredibly warm year. January, February, March, these are our biggest snow accumulation years or months in the Olympics. And you can see that they were 6 and 7 degrees above normal. And what that meant was that snow was not falling in the Olympics, but rather, you know, in the elevations of the Olympics, but rather it was rain. And you can see that in our snow accumulation from that year. This is average in the bottom left graph. You can see the black line is your average snowpack in a given year. And then the blue shows you what happened that year. And the take home on this is right here. And the mean winter temperatures when snow usually accumulates it was about 4 degrees Fahrenheit above normal. But you can see that the precipitation was pretty close to normal. It was 93%. So it was a tiny bit drier, but not much. And so it was a normal precipitation year, but a much warmer temperature year. And now we return back to the projected temperatures in the Northwest, and we see that if you project that 4 degrees, you're looking at an average temperature. This will be the normal temperature in winters by the year 2060 if these models turn out to be correct. And so as land managers and scientists, this was incredibly helpful that we had this annual data collected, because we could really see how our areas were going to respond and how our glaciers were going to respond. And to show you how unusual this was, here's Hurricane Ridge from our webcam in a normal year, 2014. And I think you guys can, I think my arrow, hopefully you can see this. There's, you can see the snow line is really low. We probably have 8 feet of snow in the meadows in front of this, in front of the Hurricane Ridge Lodge. And then here it was in 2015, instead of a snow line right down here, it's all the way up above 6,000 feet. Only the very tops of the peaks are covered with snow. And it looks more like October. The meadows are completely bare. And here's the Eel Glacier when we went in and visited in 2014. Again, a pretty normal year. And you can see everything is very snow covered. This moraine you can barely see. And here it was when we went in April in 2015. This lake typically doesn't even become exposed or melted until September in a given year. And you can see that below the very bottom of the glacier, there's absolutely no snow by April. And this should normally be the maximum snowpack. So very different conditions. And this is a little bit complicated, but I just want to kind of mention it, is one of the great things. This is data that we collect from the glaciers using the funding from Washington National Parks Fund. And one of the great things it shows is, it shows that this is the amount, this is the winter balance, or kind of the amount of ice that our snow that accumulated on our glaciers at various elevations. In this case, it's the blue. And what you see is 2014, which we called a pretty normal year. So that's these blue values right here. And notice that these are the highest elevations. So at the highest elevations in 2015, we actually had almost the same or more snow. But at lower elevations, below 6,500 feet, we had much less. And what that tells you is it wasn't about the amount of precipitation, but it was the temperature. It was just too warm at lower elevations for snow to accumulate. And so it really gives us a nice lesson about what the future will look like. Our very highest elevations will probably be okay, but our lower glaciers are going to suffer greatly. And you can kind of see that in this. This is some LiDAR drive data, but what we saw was on average, our glaciers lost about 4 meters of ice. And that's because during summer months, instead of 10 to 30 feet of snow being melted before that previous year's ice could melt, it just started melting the previous year's ice immediately because there was no snow to cover it. And so at the bottoms of our glaciers, we lost as much as 10 meters, so over 30 feet of ice in a given year. And this is again the data we've collected on each glacier using Washington National Parks Fund money. And you can see in given years, there's that 2015 was very extreme. And then there's a few positives. And then what we do is we accumulate that, kind of add that up each year, and it kind of shows our downward trend and how quickly or slowly we're dropping. And so that's kind of how we're using that data. All right, and that's it for me on this one, you guys. And I just want to acknowledge, I interpret a lot of this data and I help secure the funding and do some of the field work, but it's really been like a huge group of folks here from the University of Washington, Portland State University, of course, the Washington's National Park Fund, and then all of my colleagues here at the National Park Service, both at North Cascades National Park, here at Olympic, and over at Mount Rainier. So thank you for all those folks that have helped us with that.
Bill, thanks a lot. We have a lot of questions for you. Boy, for a first-time Zoom presenter, you really did great. So
thank you.
Yeah. Before we jump into the questions, I want to mention to everyone, this is our 8th weekly Zoom field trip, virtual field trip, and all of them are recorded and then shared on our website. If you haven't seen them, I know you would love looking through from junior ranger programs to interviews of superintendents and studies in the North Cascades. And so lots of opportunity to learn more by checking that out. Here we go with the questions. Bill, is Mount Rainier a glacier?
Well, Mount Rainier is a volcano, but Mount Rainier is definitely covered with glaciers. So yes.
That's great.
From that sense.
Somebody wants to know, I like this question. How can we fix the sun problem?
How can we fix the sun problem? Maybe that just talks about, maybe that's telling us a little bit about the issue of the melting of the glaciers. Yeah, I don't think there's much we can do about the sun. And in fact, I think we need the sun more than, possibly more than the glaciers. So we don't want it to go away completely. But I think what we need to do is just work on creating a situation where our temperatures don't continue to rise quite as much. And that comes really to global carbon emissions and conservation from that standpoint.
Who names the glaciers?
Well, over the years, most of the glaciers, names tend to be kind of historic in nature. We don't go out and name new glaciers, for instance. But most of the glaciers were named by early climbers here in the Olympics, was pretty typical, and early explorers.
Do alpine glaciers typically shrink between interglacial periods?
Oh, excuse me. Mm-hmm. Yes, I think what they're getting at is, I think what they're, oh, excuse me, sorry.
No problem.
I think what that question's getting at is that maybe in terms of like ice age periods, do they, and the idea that there is kind of a natural shift of glaciers. So for instance, 300 years ago in the Little Ice Age, our glaciers kind of reached a maximum. And so there is some natural changes that go along with shifts, kind of our natural shifts in climate. So for instance, we're moving from a really cold period 300 years ago to a slightly warmer period now. And what we're seeing is a combination of that and kind of some more exaggerated impacts from anthropogenic changes in temperature.
Thank you, Bill. Let's see. Some folks want to know, do you enjoy your job?
Oh yeah, I mean, look at this picture. How can you not enjoy that job? But yeah, I love my job. And I know I was going to argue with you about who has the best job, Lori. But no, I love my job and I'm thankful every day for it, and, I kind of keep up a little Instagram where I, get a snap a shot from so many of my fun jobs. And I love working on the coast and in the mountains. So I'm thankful to everyone that helps support me doing this, which is everyone out there. So thank you for that. And, but I do want to say that not all days look like this. And, there is some suffering that goes along with it. But yeah, on days like that, it is an awesome, awesome job. Thank you.
A few more. What is the meaning of RCP?
Oh, gosh. I do not know. I believe that has to do with the slide of the climate models. and I am not sure what that stands for.
Okay.
Yeah, I'd have to like look at that graph again and see what the context was. So if that person wants to, I don't know, can I email them an answer to that? Because I'd gladly do that.
Yep, we'll hook you up.
Yeah, okay, great. Thank you, Lori.
Yeah. Let's see, I think I'm going to end there out of respect for everybody's time. And I just want to mention, I appreciate you acknowledging Washington's National Park Fund, and we have been with you for a long time now. And there's a program coming up a week from today that if people are interested in science and research, and that is one of the areas that we fund, I know they'll find this fascinating. So if you haven't signed up, next week, Wednesday, we'll be looking at microplastics, which they're finding in the North Cascades alpine lakes. You'll be stunned by what you learn. You'll be shocked. So tune in and sign up if you haven't yet. And then 2 weeks from today, we're bringing in some special friends, the Musical Mountaineers. And I imagine some of you know about them or have seen them at our Benaroya concert in October, but they're amazing. Two women who go up, and their specialty is going into the mountains at sunrise and playing incredibly beautiful music. And they'll be sharing their story with us again 2 weeks from today. So keep tuned into our website. Bill, thank you so much.
You're welcome, Lori. Thank you, everyone.
Yeah, we appreciate it. If you want to learn more, go to wnpf.org, and we'll see you next week on our future field trip. Take care, everyone.